Welcome back. We are still on the topic graph of quadratic functions. In the previous video, we solved a likely examination question on the graph of a quadratic function. In this video, we are going to solve another question. The question for this video is: copy and complete the table below for the relation y is equal to x plus 1 times 3 minus x. B. Using a scale of 2 cm to 1 unit on the x-axis and 2 cm to 2 units on the y-axis, draw the graph of the relation y is equal to x plus 1 times 3 minus x. C. From your graph, find I, the truth set of x plus 1 times 3 minus x is equal to minus 4. II. Equation of the line of symmetry of the relation y is equal to x plus 1 times 3 minus x, and III, range of values of x for which y is greater than 0. In this video, we are going to solve the A and B part of the question. So you copy and complete this table for the relation y is equal to x plus 1 times 3 minus x, and then you use the values of x and y in the table to draw the graph of the relation y is equal to x plus 1 times 3 minus x on a graph sheet. Then in the next video, you will use the graph of the relation that we have drawn to answer the C part of the question. So let's begin with the first part. Copy and complete the table below for the relation y is equal to x plus 1 times 3 minus x. This means that we are going to substitute each one of these x values into this relation to get its corresponding y value. The relation is y is equal to x plus 1 times 3 minus x. The first x value in the table is minus 3. So we are going to find y when x is equal to minus 3. When x is equal to minus 3, y will be equal to, in the first bracket we have x plus 1. So you have minus 3 plus 1. Then in the second bracket we have 3 minus x. So you have 3 minus 3, which will give us 3 plus 3. So you have y is equal to minus 3 plus 1 times 3 plus 3. Minus 3 plus 1 will give us minus 2. 3 plus 3 will give us 6. Minus 2 times 6 will give us minus 12. So when x is equal to minus 3, y is equal to minus 12. Let's write that in the table. So when x is minus 3, y is minus 12. The next x value is minus 2. So you have minus 2 plus 1. Then in the second bracket, 3 minus minus 2, which will give us 3 plus 2. So y will be equal to minus 2 plus 1 is minus 1. 3 plus 2 will give us 5. Minus 1 times 5 will give us minus 5. So when x is equal to minus 2, y is equal to minus 5. The next x value is minus 1. When x is equal to minus 1, y will be equal to minus 1 plus 1 in the first bracket. Then in the second bracket, we have 3 minus minus 1, which is 3 plus 1. Minus 1 plus 1 is 0. 3 plus 1 is 4. 0 times 4 will give us 0. So when x is minus 1, y is 0. When x is equal to 0, y will be equal to 0 plus 1 in the first bracket, and 3 minus 0 in the second bracket. 0 plus 1 is 1, 3 minus 0 is 3. 1 times 3 will give us 3. So when x is 0, y is 3. The next x value is 1. When x is equal to 1, y will be equal to 1 plus 1 in the first bracket, 3 minus 1 in the second bracket. 1 plus 1 is 2, 3 minus 1 is 2. 2 times 2 will give us 4. So when x is equal to 1, y is equal to 4. The next x value is 2. When x is equal to 2, y will be equal to 2 plus 1 in the first bracket, then 3 minus 2 in the second bracket. 2 plus 1 is 3. 3 minus 2 is 1. 3 times 1 will give us 3. So when x is 2, y is 3. The next x value is 3. When x is equal to 3, y will be equal to 3 plus 1 in the first bracket, then 3 minus 3 in the second bracket. 3 plus 1 is 4. 3 minus 3 is 0. 4 times 0 is 0. So when x is equal to 3, y is equal to 0. The next x value we have is 4. When x is equal to 4, y will be equal to 4 plus 1 in the first bracket, then 3 minus 4 in the second bracket. 4 plus 1 is 5. 3 minus 4 is minus 1. 5 times minus 1 is minus 5. So when x is equal to 4, y is equal to minus 5. The last x value we have in the table is 5. When x is equal to 5, y will be equal to 5 plus 1 in the first bracket, then 3 minus 5 in the second bracket. 5 plus 1 is 6. 3 minus 5 is minus 2. 6 times minus 2 gives us minus 12. So when x is equal to 5, y be equal to minus 12. So we have completed the table for the relation y is equal to x plus 1 times 3 minus x. The next part of the question says that we should draw the graph of this relation on a graph sheet using a scale of 2 centimeters to 1 unit on the x-axis and 2 centimeters to 2 units on the y-axis. Let's do that. So this is our graph sheet, and these are the set of x and y values that we are going to plot on this graph sheet. The scale we are using is 2 centimeters to 1 unit on the x-axis and 2 centimeters to 2 units on the y-axis. In the video on choosing the best position for the x and y axis, which is the video number 17 in this playlist, we learned that we will have to draw the x and y axis in such a way that we can plot all these points on the graph sheet. So looking at the set of x and y values that I have in this table, I'm going to choose this horizontal major grid line and this vertical major grid line as my x and y axis. They meet at this point, so here will be the origin. The scale on the x-axis is 2 centimeters to 1 unit. So we use a scale of 2 centimeters to 1 unit to number the x-axis. And the scale on the y-axis is 2 centimeters to 2 units. So we will use a scale of 2 centimeters to 2 units to number the y-axis. Once again, we have already learned how to determine the best position for the x and y-axis. We learned that in the video on choosing the best position for the x and y axis, which is the video number 17 in this playlist. So if you want to learn more about how to choose the best position for the x and y axis, please watch the video number 17 in this playlist. Okay, so we can now plot our points on the graph sheet. The first point is minus 3 minus 12. So minus 3 on the x-axis and minus 12 on the y-axis. So we have the point minus 3 minus 12 here. The next one is minus 2 minus 5. So minus 2 on the x-axis, minus 5 on the y-axis. Minus 5 will be between minus 4 and minus 6. So we have the point minus 2 minus 5. The next one is minus 1, 0. So minus 1 on the x-axis, 0 on the y-axis. So it will be on this point. We have minus 1, 0 here. The next one is 0, 3. So 0 on the x-axis and 3 on the y-axis. 3 will be between 2 and 4. So we have the point 0, 3 here. The next one is 1, 4. So 1 on the x-axis, 4 on the y-axis, which will be here. The next one is 2, 3. So 2 on the x-axis, 3 on the y-axis, which will be here. The next one is 3, 0. 3 on the x-axis, 0 on the y-axis. So to be at this point. So we have 3, 0 here. The next one is 4 minus 5. 4 on the x-axis, minus 5 on the y-axis. So we have it here. And the next one is 5 minus 12. 5 on the x-axis and minus 12 on the y-axis. So we have the point here. We have now plotted all the points on the graph sheet. We will join them with our free hand to get a graph of the relation y is equal to x plus 1 times 3 minus x. The C part of the question says that we should use the graph that we have drawn to find I, the true set of the equation x plus 1 times 3 minus x is equal to minus 4. The equation of the line of symmetry of the relation y is equal to x plus 1 times 3 minus 4, and I, the range of values of x for which y is greater than 0. We are going to do this in the next video. So see you in the next video. Let's continue with the solution. Bye bye.